All right, so continuing to factor, if we take a look at 7, there is no greatest common factor, but 27 and 125 are both perfect cubes. So we're going to use the sum of cubes to factor. So again, that pattern for this one is going to be a plus b, and then a squared minus a times b plus b squared. So again, to get a, we take the cubed root of the first term. So the cubed root of 27 is 3. Cubed root of x cubed is x. So a is the same as 3x. And then b, we take the cubed root of 125, which is 5. And now we are just substituting in and simplifying. So for the first one, we're going to have 3x plus 5. In the second group, when we take a squared, we are squaring this whole group. So that means that we have to square 3 and the x. So this is going to become 9x squared minus, and then a times b. So 3x times 5 is 15x. And then plus b squared. So 5 squared is 25. And then there's nothing else that we can do to simplify because this one is going to be prime. So that is our final factored answer. All right, next problem, problem 8. There is no greatest common factor. Our highest power is a 2, and we only have 2 terms. So looking at this, I'm trying to decide if that's going to be the difference of squares. And both 9 and 49 are perfect squares, so we can use our difference of squares factoring. So to do that, we take the square root of the first term, so this will be 3x, and that goes first in both. Square root of the second, so square root of 49 is 7, and then we're going to have one positive sign and one negative sign. So this is our final factored answer. All right, problem 9. There is no greatest common factor. We have 2 terms, and the highest term is a 6. Well, actually, sorry, the highest power is a 9. So for this one, if it's factorable, it has to be the sum of cubes. And we can rewrite this to make it look like the sum of cubes. So really, this means the same thing as saying x squared to the third power plus y cubed to the third power. So now I've created that sum of cubes, excuse me. So now when we factor, it's going to have to factor into a plus b times a squared minus a times b plus b squared. So for this problem, a is x squared and b is y cubed. So we're just going to substitute into that pattern. So the first group is x squared plus y cubed. And in the second group, so again, we're squaring this whole thing. So 2 squared squared is going to be x to the fourth. And then here we're taking x squared times y cubed. So that's just going to be x squared y cubed. And again, we're squaring this whole group. So y cubed squared is going to be y to the 6th power. And there's nothing else that we can do to keep factoring. So that's just going to be our final answer. All right, next problem. So again, looking at this, we do have a greatest common factor. So we can factor out a y and a 5 from each of these. So from the first one, if we factor out 5y, we're going to have y cubed left. And then 320 divided by 5 is going to be 64. And then we'll still have z cubed. Now looking at this problem, we aren't actually done because we have the difference of perfect cubes. So we have y cubed as a perfect cube, z cubed as a perfect cube, and so is 64. So that means that we have to keep factoring. So the 5y is just going to tag along, but we're not going to change anything to it. And then this part's going to factor into that a minus b, and then a squared plus a times b plus b squared. So a for this problem is just y to the first, and then b is going to be 4z. So now I'm just substituting. So this will be y minus 4z times y squared plus 4yz, if we multiply those together, plus, and again, we're squaring this whole term, so 4 squared is 16, and then we will have z squared. And then the 5y is just going to sit in front. So this whole thing is our final factored answer.